Okay, guys, so let's get started without any further ado. I think the others might be joining shortly. Again, for those who are joining the session for the first day, to just give you some context, we have been taking these classes for the last 3-4 days. We have taken the demo on what certified ethical hacking is. And after that, we've started the first topic in the course, which is networking fundamentals. Okay, so just in case if you haven't watched those videos, they're available on YouTube. You can just search for cybersecurity DURGASOFT and filter them by recently uploaded. And you can actually find all the seminars and the demos here. So this was a seminar taken on Sunday at 10 a.m. And then after that, these are all the demos. Demo 1, and this is demo 3 here, and this is demo 2 as well. Yeah, demo 2 here. Okay. So these are all the sessions which we have covered in the earlier sessions regarding the again the introduction to ethical hacking and also the networking fundamentals. Okay, so if time permits, please go through those recordings, guys. Okay, this is again on again what we've covered earlier. Now coming to the topic that we're going to cover today, let's talk about the classes. So in your IPv4 addresses, there are multiple classes, class A, B, C, D, and E. We have covered the range of them. Today we're going to talk about the relevance of each of these classes. Why do we have 5 separate classes, and what's the importance of each class? Okay, so firstly, we need to know that each class has a specific number of network and host portions. Class A has one network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. Class D and Class E have all network portions itself. There are no host portions in them. Okay. To understand what these network and host portions are, let's take the example of Class C first. Okay. So as you're going down the line, the network portions are increasing in number and the host portions are decreasing, if you notice. So class C has 3 network portions and only 1 host portion. So let's take the example of this. So your class C private IP range starts at 192.168.0.0. As mentioned in the previous slide, this is the IP, private IP range from class C. 192.168.0.0 to 192.168.255.255. So let me write down the same range in a notepad file to explain what these classes are. So now, as mentioned, this is the class C range, starting in 192.168.0.0 and going up to 192.168.255.255. So if I write down the first IP here, in this IP, the first 3 portions are network portions, and the last portion is the host portion. Now forget about network and host portions for a while. If we talk about the sequence, if this is the first IP, 192.168.0.0, next IP would be 192.168.0.1. So according to the sequence we learned in the earlier sessions, the rightmost octet increments by 1. So you have 0.1, then 0.2, then 0.3, then 0.4, which goes all the way up to 0.255. Now, as long as the last portion, the host portion is changing, it just indicates a change in the host. So the 0.1 could be assigned to my Wi-Fi router, let's say. 0.2 could be assigned to my laptop. 0.3 could be assigned to another device, let's say smartphones. 0.4 could be assigned to another device, let's say a smartwatch. Okay. So each unique host portion indicates a unique host. Okay. And the network portion gives you the identity for the entire network. So all of these IPs belong to the 192.168.0. network. And whenever hosts belong to the same network, they can communicate with each other. So this Wi-Fi router is capable of communicating with all the other IPs in the same network. Okay. But when the network portion changes, so after 0.255, you have 1.0. So whenever there's a change in the network portion, that divides the network as well. So from here, after 0.255, you have 1.0, which is a completely different network again. And from 1.0 to 1.255, that's one whole network with again 255 IPs in it, which can communicate with each other. Okay. So the host portion gives you the identity for the host in a network, and the network portion gives you the identity for the entire network itself. Okay, that's the relevance of network and host portions. And in class C, with 3 network portions and 1 host portion, in every network, you can connect a maximum of 255 IPs. So from 01 to 0255, 10 to 1255, 20 to 2255, 30 to 3255. In every network here, you have 256. Actually, to be precise, it's 256 hosts, but we never use the 0.0 IP and 0.255 IP. They're called as network ID and broadcast ID respectively. Okay, but to round it up, let's assume there are 255 IPs in each network. Okay, so that's the speciality of Class C. In Class C, in each network, we can only connect a maximum of 255 devices, not more than that. But if you have a network which needs more than 255 devices in it, then you have to go for the next class, which is Class B. So in Class B now, you have two network portions and two host portions. So the first private IP in Class B is 172.16.0.0. Right? Out of that, the first two portions are network portions, and the last two portions are the host portions. Okay. So if 00 is the first IP, the next IP you have is 01, then 02, then 03, then 04, then 05. Goes all the way up to 0255. Now after 0255, you have 10. But here the network doesn't divide because even this third octet is also a host portion. So 0255 can still freely communicate with all the other IPs below it because, as mentioned, the third octet is also a host portion octet. In class, excuse me. In Class C, that was not the case. 0255 could not communicate with 10 because the third octet was a network octet. Okay, but in Class B, the third octet is also a host octet. So 0255 can now communicate with all the other IPs below it with 10, 12, 11, sorry, 11, 12, 13, 14 up to 1255, then 20, 21, 22, 23 up to 2255, 30, 31, 3233 up to 3255, which goes on, and somewhere down the line you would have 2550, 2551, 2552, 2553, and 255, 255. Once both these octets are full, they cycle back to zeros and the next octet changes or increments by one. So 16 changes to 17. And whenever there's a change in the network portion, there's a change in the network itself. So all the IPs from 172.16.0.0 to 16.255.255 belong to one single network. Okay, but when 16 changes to 17, the network divides it, and from 17.0.0 to 17.255.255, that's the next network. 18.0.0 to 18.255.255, that's the next network. 19.0.0 to 19.255.255, the next network. This goes on all the way till the last network, 31.0.0 to 31.255.255. So now in each Class B network, the total number of devices you can connect is 255 into 255 because the fourth octet is repeating 255 times for every third octet change. Okay, and this third octet itself is repeating 255 times. Okay, so 255 into 255. Oh, Pankaj, you have raised your hand.
Sir, is there any tool to that means find which one is a private IP or public IP or classes, because it's very difficult to understand or remember all these things.
There's no app or anything. You just have to remember these four numbers, Pankaj, as mentioned. Were you there for the last class, Pankaj, by any chance? I've shown you that
Yes,
you
sir.
only have to remember these four numbers. That's the only way to
Yes,
remember
sir.
the class names. And other than that, these are the IPs which we regularly use in our networks day to day. So it's only the only thing is you have to remember them by heart. Okay. Or alternatively, you can just again copy paste the number in Google and ask if it's a private IP or not and which class it belongs to. That's the only other alternative. Okay. But otherwise, as you keep using this, you'll easily remember all of this. These are the only four numbers. So class A 0 to 127, class B 120 to 191, class C 192 to 223, class C 224 to 239, and class C 242 to 55. On the left side, you have all even numbers. On the right side, you have all odd numbers. Okay. That's the class thing. And for private IPs, you have to remember 10, 17, 16 to 1731, and 190 to 168. That's all. So it's only those numbers that we have to recall. And no, I don't think there's an app or anything else specifically. But yeah, you can do a quick Google search and figure out which IP is which. Okay,
Okay, sir.
right. Finally, coming to class A now. So as mentioned in class B, you can connect in each network a maximum of 255 into 255 IPs. To be precise, it's 65,535 devices. And finally, when you come to class A with one network portion and three host portions, all the IPs from 10,000 to 10,255, belong to one single network. And in this one single network, you can connect a maximum of 255 into 255 into 255 hosts. So the reason you have different classes is to basically define the network size. Class C can be used for small networks. So your home networks, your local organization networks, which are small, medium to small sized companies, they go for Class C private IPs. If it's a larger company, a multinational company also, which has a requirement for connecting more than 255 devices in each network, then you can go for Class B or Class A, anything. Class D and Class E do not have any private IPs in them. All of them are public IPs itself. But these public IPs are special. So the reason I call them special is because they're not given for the internet access. When we talk about internet access public IPs, they only come from Class A, B, and C. Okay. But Class D and Class E public IPs are reserved for special organizations, research and development organizations, military organizations, or police, all over the world, whatever police organizations are there for their own separate, again, special private networks, okay, and for weather forecasting and broadcasting services. So such organizations are going to use Class D and Class E public IPs. They're not given to the general public for internet access. For our internet access, we get the public IPs only from Class A, B, and C. Right? Class D and Class E are reserved for these other, specific exclusive, organizations or special organizations. Okay. Yeah, just a sec. Any questions or doubts regarding these classes, guys, before we go into the next topic of how to assign a private IP? Any questions? Pankaj, Rahul?
No.
No, sir.
Yeah, okay. Well, moving on. Let's talk about how do you assign a private IP. Oh, before that, subnet mask. So sorry. So now I have shown you in one of the earlier sessions how do you check your private IP, guys. So if you go to your command prompt CMD and if you type IP config here, this shows you your private IP. As you can see, this here is my IP address 192.168.0.2. I'm getting a private IP here. Now, under that, you see something called subnet mask. So what is the subnet mask? So subnet mask is for a computer to understand which IP belongs to which class. Now, as we humans, we can understand which IP belongs to which class from the network and host portions. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. We all know this. But how does a computer differentiate between network and host portions? How does it know which one is network and which one is host? So what a computer or any information system for that matter does is it assigns the network portion with the value of ones and the host portion with the value of zeros. Okay. So wherever there's a network portion, I've put all ones in that octet. Wherever there's host portions, I've put all zeros in that octet. And now when I convert that from binary to decimal, you get the class A subnet mask as 255,000 for all ones 255 and for all zeros 0. So when you see the subnet mask of class A for a device, it understands, okay, I belong to class A. I can connect a maximum of 255 into 255 into 255 devices. It knows its range, it knows the number of devices it can connect to and what its network size is. Okay. So class B, on the other hand, with two network portions and two host portions is 255,255,000. And for class C, with three network portions and one host portion, subnet mask is 255,255,255,0. If you observe here, that's the same thing I see. 255,255,255,0. So from this subnet mask, it understands, okay, this IP belongs to class C. And I can only connect with a maximum of 255 IPs, starting from 0.1 to 0.255. Okay, it understands its range, the size of the network, and its class A or B or C. Okay. Then under that, you have something called default gateway. Now, this is the name given to your Wi-Fi router, which is acting as a gateway between the two networks and usually gets the first IP, 192.168.0.1. Okay. So the first IP in the network is assigned to the Wi-Fi router, and that is also commonly known as default gateway. Okay. Now with these pieces of information, we can learn how to assign an IP address as well. Okay. So, excuse me. So if you have to assign a private IP, guys, there are two ways for it. One, you can manually assign it yourself from the control panel. That is one method. In the olden days, if you were the network administrator, it was your responsibility to go to every system in the network and check if they're getting an IP or not. You have to assign it yourself. But this works for small networks. For larger networks, you cannot send a network admin to every device and assign the IP. You use something called a DHCP server. So I'm going to show you both the methods. How do you assign it manually? And how do you assign it automatically with the DHCP server also? Okay. Right. So when you talk about the manual method of this, you have to open up your control panel. So you have to search for control panel. In the control panel, you have to go to network and internet settings, then network and sharing center, then change adapter settings. And then you have to right click on the adapter for which you want to change the IP. So if I click on properties here, I have IPv4 properties, Internet Protocol version 4 properties. And you can see these are the two methods I can get an IP. I'm right now getting it automatically from a DHCP server. But if I want a manual IP, you can select the second option here. I can manually type the IP, something like 192.168.0 dot, let's say 100. Now this is a class C IP, so the subnet mask is 255.255.255.0. Okay. And the default gateway is my router's IP, the first IP, 192.168.0.1. Okay. Now, along with that, I need to assign the DNS server IP also. Now, don't worry what a DNS server is. I'll explain that shortly. But just in case, if you don't know what to enter there, search for Google DNS server IP. This will provide you two IP addresses. One is 8.8.8.8 and the other one is 8.8.4.4. And you can use any of these Google's public DNS server IPs, 8.8.8.8 or 8.8.4.4. Or you can also ask your network administrator what the DNS server is, and they can give you that IP and you can assign that also. If not, if you don't have that access, you can assign these IPs, which will still work exactly the same way. Okay. And as soon as I click on OK, my system will get that IP. But I don't want to do that because if I change my IP, we might lose the network connection and the class might end. Okay, so I'm just going to go back to obtain IP address and DNS server automatically. Okay, so if you're the network admin or if you have to configure an IP manually, that is the procedure to follow. Okay, works for small networks, but for larger networks, we prefer something called a DHCP server. Okay, excuse me, a bit of a cold. So now, when you talk about DHCP server, this is this is standing for Dynamic Host Configuration Protocol server. So it is to basically dynamically or automatically configure an internet protocol address to every host in the network. So it is capable of automatically assigning an IP to each system in the network. And that happens with something called the DORA process. So no matter how many devices you have in the network, your DHCP server has a pool of free IPs. And from that pool of free IPs, it assigns each unique device a unique IP with the DORA process. And now let me explain what that DORA process is. Okay. So let's say, again, now you might have a question, where is the DHCP server in our home network? So in the home network, your Wi-Fi router itself is the DHCP server. So I have my Wi-Fi router here. This is also acting as my DHCP server. And this is getting the first IP in the network, 192.168.0.1. And your DHCP server has a pool of free IPs. Okay, so the pool can start at the next IP, 0.2, 0.3, 192.168.0.4, goes on all the way up to 192.168.0.254 and 255. Okay, so whenever there are devices in the network connected to the DHCP server, they automatically get an IP from the DHCP server with the DORA process. Okay, so with that DORA process, they get an IP assigned. So let's say if this is getting assigned 192.168.0.2, and if this is 0.3, as soon as those IPs are assigned, they are removed from the pool. Okay, so the pool will not have those IPs anymore. Okay, so now the pool will start at 0.4, 0.5, and 0.6. Okay, and let's say now you connect one more device in the network, a new device, and it's selected on that option, obtain IP address automatically. Now what happens in the DORA process is first, it sends a discover packet. So basically it is sending a packet to every system in the network. It broadcasts the discover packet. Now you might have a question, how does that happen? So if you remember, there's an IP called a broadcast IP. So this last IP is called the broadcast IP. Whenever you send a packet to this IP, it is sent to every device in the network. Okay, it's like from one to all. Okay, and this packet is called the discover packet. So first it's checking or asking every system if they are the DHCP server. So it is asking this device, are you the DHCP server? It doesn't respond back. Sorry. Then it asks the system, are you the DHCP server? It doesn't respond back. Then it is asking this actual DHCP server, are you the DHCP server? That server responds back. It says, hey, I'm the DHCP server in this network, and I can offer you an available IP. So it offers the next available IP, which is 192.168.0.4. For that offer, your client says, oh, thank you. I request you that you allocate that IP to me and do not assign it to anybody else. Okay. So a request is made there. And for that request, your DHCP server sends an acknowledgement, a confirmation saying, oh, perfect. I acknowledge your request and this is my confirmation or acknowledgement for it. And with this acknowledgement, it gets the IP 192.168.0.4 and, oh, sorry, 0.4. And as soon as that IP is assigned here, it is removed from the pool again. So now the pool will begin at the next IP, which is 0.5. Okay, so that is how, again, IPs are assigned. And this procedure is called the DURA procedure. D for discover, O for offer, R for request, and A for acknowledgement. And I'm pretty sure you have observed this at least once in your life. So whenever you connect a phone to a Wi-Fi router for the first time, after you enter the password, for a very short duration, you see this message, obtaining IP address. I'm not sure how many of you have observed that, but that is where your phone is performing the DURA process with your router, and then it gets the IP assigned. And once the IP is assigned, then it shows connected. Okay, so that's where the DURA occurs. And I have to show you what the DHCP server looks like. I can go to my browser, I can log into my router. This is my router at my home network. I'm using a TP-Link router here. And if I go to my network settings and LAN settings, you can see my TP-Link router itself is acting as a DHCP server. It's getting the first IP in the network and the remaining IPs are in the pool. So I'm not using all the 255 IPs, I'm using only up to 199. And from those range of free IPs, these are the IPs assigned to each system. 0.2 is assigned to my desktop, 4 is assigned to my phone, 8 is assigned to another phone, 109 is assigned to my Kali operating system. These are all the devices in my network here. Okay. So yeah, that is what a DHCP server is, and this is how you get IPs automatically. Okay. Now talking about the DNS server. Oh, before that, any questions or doubts up to this point? Pankaj, Rahul.
No.
No, sir.
Right. Okay. So now moving on. So let's talk about something called DNS servers. To understand DNS servers in the simplest way possible, you can take the example of your contacts app in your phone. So what does the contacts app do in the phone, guys? It is to link a contact name with the contact number. So if you get my phone number, first thing you do is you assign it a name and you save it. Okay. Cybersecurity trainer, Shoaib Cybersec or whatnot. Okay. So next time you want to call me up, you search by the name and you place the call on that contact name. But the connection there is not happening on the contact names. The contact name is only for you to recognize who that number belongs to. The connection always happens from your 10-digit SIM card to my 10-digit SIM card. Okay. So in a similar fashion, if you open up your browser and in the browser, when you search for a domain name like this, www.google.com, your browser doesn't understand this domain. It doesn't understand this language. When it wants to connect to Google, what it actually needs is the IP address of google.com. So somewhere on the internet, there's a server called google.com with that domain or host name, and it needs a public IP to be available on the internet. So what your browser actually needs is that public IP of that server, because all the internet traffic that flows on the, again, from the ISP servers to all the web servers on the internet flows on IP addresses, not on domain names. Okay. So now that request now first for google.com goes to the ISP, and then the ISP sends a request to a DNS server. So these are called as DNS requests. And from here, your DNS server has a huge database of all records like this. Okay. These are called as host records, where it has link between every domain and every public IP corresponding to it. Okay. So google.com is stored on so and so IP. Bing.com stored on so and so IP. YouTube.com stored on so and so IP. Show.com stored on so and so IP. So here there's a record for every domain and its corresponding IP address. And when that IP address is known, it then reaches the Google server. Okay. Oh, Pankaj, yeah, you've raised your hand.
Sir, who's on the DNS server?
Most of the times it's the companies, that company google.com itself, they have their own DNS servers, or your ISPs also maintain their own DNS servers with these records. If your ISP does not have that information, it will contact the next ISP DNS server. If they don't have the information, then they'll contact the organization itself, google.com itself, to figure out what their DNS server's IP is, and from there they get that information. So it's a network of DNS servers all over the internet, from various internet service providers, or from, say, various content delivery network devices, organizations like Cloudflare, or the direct companies itself. Okay, Google, Google, Microsoft, they all have their own DNS servers with their records like this, and they're publicly available on the internet. Is that clear, Pankaj?
Yes, sir.
Right. So DNS server is like the internet's phone book, translating or converting human readable domain names into IP addresses. Okay. So when you search for a URL in your browser, first that URL is sent as a request, a DNS request to the ISP. And ISP tries to fetch that information from any DNS server closest to it. It tries to figure out where is that domain located, what is the actual IP address for that domain. And from that IP address, it reaches the corresponding web server. If I have to show you an example for this, I can open up my browser. Okay. And when I connect to google.com, I can either connect it this way, www.google.com. This is one way. Or alternatively, I can go to my command prompt. I can run a command ping google.com, and I'll get an IP here. Oh, I'm getting an IPv6 IP here, not an IPv4 address. Just a second. Don't worry about those commands. Yeah, I've got an IPv4 address as well, as you can see, 142.250.182.78. I can copy that IP. So NSLOOKUP is a command called DNSLOOKUP to get the DNS records for Google. I've got the IPv6 record and the IPv4 record as well, the IP. And if I copy this IP, and if I go to my browser, and if I paste it here, and if I hit enter, you can see it still opens google.com. But we don't have to remember this IP address anymore, thanks to a DNS server, because your DNS server is converting that domain name into these IP addresses respectively. Okay, so this is what the record looks like. Okay, so it's linking every domain with its corresponding IP over the internet. Okay, is that clear? Any questions or
Sir,
doubts?
that means hosting company or domain company provide us to IP address in the form of domain name.
Oh yeah, definitely. If you're going with companies like hosting companies like GoDaddy or Big Rock or so, again, there's a concept of shared and dedicated hosting there, where on one single IP they can host multiple websites also. So for each website, they'll assign a separate port number again. Okay. So Google is dedicated hosting. On one IP, you only have one website, so you can actually again access it with just one single IP like this. Okay. But sometimes they are shared hosting platforms. So your Big Rock, GoDaddy, Hostinger, they'll host your website on a server, and that server is given a public IP. And with that public IP, you can access that website. Okay. If it's dedicated hosting, if it's shared hosting, you have to enter the exact port number also on what port that IP is having that specific website located. Okay. Is that clear? Okay.
Yes.
Right. So I think we have covered almost every topic that is required for networking fundamentals. There's one last concept called special IPs. Again, we'll just leave this for the next class on Monday. So I have to explain what loopback IPs are, PIPA IPs are. Strength is a bit low. I think again, students are registering. If you guys haven't registered already, please do register, guys. In the next session, we'll be covering this last topic called special IPs, and we'll start with the next practical session. How do you install VMware? So I'll show you how to install this application called VMware, which is a virtualization software. And in this virtualization software, we'll be installing this operating system called Kali Linux operating system. So that will be the next session, which I'll be taking on Monday. Okay, a practical session to have the lab simulation ready for our upcoming sessions. Okay, so this is a lab that you'll be using for the entire course. Okay, and I'll explain the lab simulation from Monday onwards. Okay, so as mentioned, guys, these are the demos that we've taken over the week. If you have not joined the earlier demos, no worries. All these sessions are being recorded and they are uploaded on YouTube already. Okay, you can access those recordings from there. To get complete information on what topics we'll be covering throughout the entire course, you can also access the seminar recording, which I took on Sunday. You just go to YouTube, DURGASOFT, cybersecurity. Okay, filter by recently uploaded, and this is the seminar. the whole 1 hour, the whole 1 hour session which we took the other day to explain what the entire course is about, what modules we'll be covering, what tools we'll be working on. So this is a complete demo, okay, on understanding what the whole course is about. Okay, so please access this recording here. For if you want, I can just drop this link in the chat box directly. Just a second. Zoom, yeah. So this is the seminar link as well. Okay, so as mentioned, this is the last demo, guys. I hope you have registered already. If not, please do register at the earliest to to continue our further sessions from Cybersecurity CEH official ethical hacking course. Again, a very important course, as mentioned, for people who want to start getting jobs in the cybersecurity domain. Covers everything from scratch up to basic, from the very basic side up to intermediate and expert level to understand penetration testers, job role, and the tools and techniques they use in their day-to-day work life. Okay, so yeah, that's that. Any questions or doubts before we exit our last demo today? Pankaj, Rahul.
Sir, how many classes remains from right now?
So we're just done with 3 classes, Pankaj. So we have 32 sessions more remaining of the actual practical classes for the course.
Okay.
Right. And we have sessions from Monday to Friday, every day for 1 hour each at the same time slot. Okay. So yeah, that's it. Nothing further. Oh yeah, Rahul, any questions on here?
No, sir.
Okay, guys. So please do register if you haven't registered already and contact the institute for any further details regarding the payment or the installments or anything as such. Okay.
Okay, sir.
You can contact the institute, Pankaj, regarding that. So they'll let you know because again, the institute also offers, I think, installments. I'm not sure. I don't have exact information regarding the installment. Yeah. They have the installation. The installment thing. Give me installation. Which installation, Pankaj? Oh, installment. Oh, yeah. I think they've mentioned the contact link in the chat, right? These are the phone numbers from DURGASOFT. You can connect with them on any of those numbers.
Okay, sir.
Yeah, they provide that installation thing. Sorry, I'm confusing between these terms. Installments, Pankaj. They provide the installment speak feature as well. So you can contact the institute on any of those numbers which I've mentioned in the chat there. Okay. So that's that. Nothing further. We can exit the session here, guys. I'll connect back with you on Monday for our next session. Bye-bye. Good day.
Thank you, sir.
Thank you, guys. Bye-bye. Yeah, Pankaj, you were saying something. Okay.
Sir, hello.
Oh yeah, Pankaj, I'm here.
Sir, I want to complete from your guidance from your side for a CS certification.
Oh yeah, I'll be providing that, Pankaj. As mentioned, once the course is done, you'll be ready to write the certification. If not, the thing is, I don't think I've mentioned that clearly earlier. We do provide proxy support as well. So if you're planning on writing the certification exam, even
Yes,
with
sir. Yes.
not so sure confidence, I'll provide that help. Don't worry. But the only thing is, you have to be in
Okay.
Hyderabad for that. So because I have a center here.
No, sir. I will come. I will come for that, sir. No
Okay,
problem.
sure, no problem. I can
Okay.
handle
Thank you,
that.
sir.
That's not at all a problem.
Good day, sir. Thank you, sir. I will talk with team about the fees.
Yeah, sure. Have a good day. Bye bye.
Okay. Thank you.